Today we're going to talk about literal equations. And a literal equation is an equation with multiple variables. And I'm going to start by comparing literal equations with the equations we've been solving for the past few weeks. The equations we've been working with have taken this form: 2x plus 4 equals 6x plus 8, where we have x in two different locations, but it's the same variable, so we have one variable in two different locations. An example of a literal equation would be 2x plus 4y equals 10. So we have two different variables, x and y, compared to the equations we've been working with where we have just x and x. I want to look at some examples of literal equations, and our literal equations are typically formulas. So if I have a triangle and I want to find the area of a triangle, well, I have the base of that triangle, I have the height of the triangle, so my area would be equal to the base times the height divided by 2. So I have three variables: base, height, and area, making it a literal equation. If I want to find the area of a circle, well, I have the radius of the circle, so I'm going to take pi, or 3.14, times the radius to the second power. So my variables in this equation will be a and r, area and radius. And our objective when we have a literal equation is to isolate a variable. So we want to get one variable by itself. And to do that, the method we're going to use is by identifying the steps to build and solve the equation. So let's go back to our triangle example from the previous slide. So we know that the area of a triangle equals base times height divided by 2. So let's say we wanted to isolate h, so isolate the height for this equation. So let's go through our steps to build the equation for h. So the first thing that's happening to h is we're multiplying by b, by the base, then we're dividing by 2. And our steps to solve the equation, so let's start by undoing that last step. So we're going to undo dividing by 2 and multiply by 2. And then I'm going to undo multiplying by b and divide by b. All right. So what this is going to look like, I'm going to start by multiplying the left and the right side by 2 and 2. 2's cancel out on the right, so I'm left with 2a equals base times height. I'm going to divide both sides by b and b. The b's on the right cancel out. I'll have 2a divided by b equals the height. So let's look at the original example that I gave you of a literal equation, the 2x plus 4y equals 10. Let's say we want to isolate x. So our build, well, the first thing that's happening to x is we're multiplying by 2. Then we're adding 4y. So our solve, let's start with undoing the adding 4y and subtract 4y. Then we're going to undo multiplying by 2 and divide by 2. So let's subtract 4y and 4y from both sides. The 4y's on the left cancel out, and I'm left with 2x equals 10. But now the 10 and the 4y aren't like terms, so I can't subtract them. So I'm just going to write it 10 minus 4y. So in my first step for solve, my second step for solve, I'm going to divide both sides by 2. So divide by 2 and 2. 2's on the left cancel out. And I'm going to divide everything on the right side by 2, the 10 and the 4y. So I'm left with x equals 10 minus 4y divided by 2. Now I notice one thing, the 10 and the 4 are both divisible by 2. So I could break that up a little bit further and have 10 divided by 2 minus 4y divided by 2. And then 10 divided by 2 gives me 5, minus 4 divided by 2 gives me 2y. So let's look at the equation negative 3x minus 8y equals 16. And for this, I want to isolate y. So our steps to build, well, the first thing that's happening to y is it's being multiplied by negative 8. We have a minus sign here. I'm going to keep that minus sign with the 8. Then, if we look at the 3x, the sign on the 3x is negative, so 3x is being subtracted from the equation. So we're multiplying by negative 8, then we're subtracting 3x. Pause the video here, guys. Take a second, write your steps to solve this equation for y. So our solve to isolate y, we're going to start by undoing the subtracting 3x and add 3x to both sides. Then we're going to undo multiplying by negative 8 and divide both sides by negative 8. So let's start with adding 3x to both sides. So plus 3x and plus 3x. Negative 3x plus positive 3x cancels out, and I'm left with negative 8y equals 16 plus 3x. Again, the 16 and 3x aren't like terms, so I can't add them. I'm just going to basically bring this 3x from the left side to the right side using addition. Next, I'm going to divide by negative 8, so I'm going to divide everything on the left side by negative 8 and everything on the right side by negative 8. Negative 8's cancel out on the left, and I'm left with y equals 16 plus 3x divided by negative 8. Now I notice, well, I can divide that 16 by negative 8. So I'm going to break this up even further, and I'm going to have y equals 16 divided by negative 8 plus 3x divided by negative 8. 16 divided by negative 8 gives me negative 2. I can't divide 3 and 8 and not get a decimal, so I want to keep this as a fraction. But I'm going to divide the positive by a negative, and my sign is going to be negative 3 over 8 times x. For our next literal equation, let's use the formula for area of a trapezoid. For a trapezoid, we have two bases, base 1, base 2, and the height. So our formula for area is base 1 plus base 2 times the height divided by 2. And for this, I want to isolate base 1. So my steps to build, yes, take a second, pause the video, and write your steps to build to isolate base 1. So our steps to build, we're going to start by adding base 2, then we're multiplying by the height, then we're dividing by 2. So let's undo those steps for our steps to solve. So our steps to solve, we're going to start by undoing dividing by 2 and multiplying by 2. Then we're going to divide by h, divide by the height, and then we're going to subtract base 2. So let's start with multiplying both sides by 2. So I'll multiply the left side and the right side by 2 and 2. The 2's cancel out on the right, so I'm left with 2 times the area equals base 1 plus base 2 times the height. Next, I'm going to divide both sides by the height, so I'm going to divide the right side and the left side by the height. Heights on the right side cancel out, so I'm left with base 1 plus base 2 on the right equals 2 times the area divided by the height. And lastly, I'm going to subtract base 2 from both sides. So I have minus base 2 on the right and minus base 2 on the left. The base 2's on the right cancel out, and there's no subtraction I can actually do. I'm just basically moving that base 2 from the right side to the left side using subtraction. So on the right side, I'm left with base 1 equals, Then I have 2 times the area divided by the height minus base 2. And that's our new literal equation after isolating base 1. So let's do one more, little more complex literal equation with 2 times the quantity xy plus z equals 8. And for this, I want to isolate y. So take a second, pause the video, and write the steps to build and solve to isolate y. So our steps to build the equation, we're multiplying by x first, then adding z, and then we're multiplying by 2. So then our steps to solve for y, we're going to start by dividing by 2, then we're going to subtract z, and then we're going to divide by x last. So let's start by dividing the left and the right side by 2. 2's on the left cancel out, so I'm left with xy plus z equals 4. Then I'm going to subtract z and z from both sides. Z minus z cancels out, so I'm left with xy equals, and again, 4 and z are not like terms, so I'm going to write this 4 minus z. I'm basically just bringing z from the left side to the right side of the equation using subtraction. Lastly, I'm going to divide the left side by x. I'm going to divide everything on the right side by x. X's on the left cancel out, and I'm left with y equals 4 minus z divided by x. So we've taken our original equation and gone through our 3 steps to get y by itself, and I'm left with, this is our equation for y.